Welcome to a video on the T formula. So the T formula uses a substitution, and it's really only one that is recommended to use if it's asked for. So, well, that's my opinion. But on the formula sheets, you get T equals tan A over 2, then sine A is equal to 2T plus 1 over 1 plus T squared. Cos A is equal to 1 minus T squared over 1 plus T squared, and tan A is equal to 2T over 1 minus T squared. So how to prove it? So we start with the double angle formula. So tan of 2 alpha, we know is equal to 2 tan alpha over 1 minus tan squared alpha. So therefore tan of just A, or just alpha if we were using the above, but tan of just A is equal to 2 tan A over 2 minus over 1 minus tan squared A over 2. But since we're letting T equal tan A over 2, you get tan A equals 2T over 1 minus T squared. So there's the tan formula that's on your formula sheet. So let's use that in our triangle and use Pythagoras. So 2T's on the opposite and 1 minus T squared is on the adjacent. If we use Pythagoras, so the distance squared, so the distance of the hypotenuse is 2T squared plus 1 minus T squared all squared. So that gets you 4T squared plus, and then the expansion of that second one is square the first, twice the product, square the last. Simplify, that gets you T to the 4 plus 2T squared plus 1. That happens to be a perfect square. So therefore D squared is equal to T squared plus 1 all squared. So the hypotenuse is T squared plus 1. Which means that we can come up with our other formulas. So sine A is obviously opposite over hypotenuse, so 2T over 1 plus T squared. And cos A is 1 minus T squared over 1 plus T squared. These are on your formula sheet, so you don't need to remember, but you may be asked to prove. So here's two examples. Using T equals tan of A over 2. Now these have both come from HSC, so it did actually say using that substitution or otherwise. So the recommendation is if they're suggesting it, then it's easy enough to use it. So we'll do that. Both of them you'll know is a left-hand side equals a right-hand side. So let's work our way through. So left-hand side is 1 minus cos A over sine A. So replacing cos A and sine A with their T formulas. And then we're going to do something that's a little bit different because we have two fractions and both fractions have 1 plus T squared as their denominator. If I multiply every term by 1 plus T squared, that will eliminate it off the denominators, and the one at the front will also be times by 1 plus T squared. So multiplying everything by 1 plus T squared, I get 1 plus T squared minus the 1 minus T squared all over the 2T. So expanding that top bracket and collecting like terms, you get 2T squared over 2T. Simplifying there, you get T. And that's what we're after because T is tan A over 2. And that's what we were asked to prove. So it equals the right-hand side. Second one, prove that cosec plus cot equals cot A over 2. Now we've got to remember that cosec is the reciprocal of sine. So what the T formula for sine is, we'll flip that. And cot is the reciprocal of tan. So left-hand side is 1 plus T squared over 2T plus 1 minus 2T squared over 1 minus T squared over 2T. Both got a common denominator, so collect your like terms on top and you get 2 over 2T. 2 over 2T is the same as 1 over T, which is 1 over tan A on 2, and the reciprocal of tan is cot. So therefore that's the right-hand side. Thank you.